Cell potentials. The energy released by the flow of electrons due to this spontaneous reaction can be used to perform electrical work. Voltaic cells are also called galvanic cells, electrochemical cells, or batteries. The cell potential under standard conditions can be found through this equation. E0 cell equals E0 SRP of cathode minus E0 SRP of anode. Because cell potential is based on the potential energy per unit of charge, it is an intensive property. This means, well, the intensive part means that it does not depend on the amount of substance, e.g. the mass or moles. The greater the difference between the two electrode potentials, all right, here's your cathode up here, and here's the anode here, the greater the voltage of the cell. So E0 cell is the SRP of the cathode, which is 0.34, minus the SRP of the anode, minus 0.76, and you get 1.10 volts. That's the voltage of the cell. Let's work an example. Use this diagram and the given half reactions to A. Identify the cathode and anode, B. Write the oxidation and reduction half reaction equations, C. Determine the complete balanced redox reaction equation, and finally determine E0 cell. Identify the cathode and anode. The anode is the electrode at which oxidation occurs, which is the electrode with the most negative cell potential. That's going to be nickel. Therefore, the nickel electrode is the anode and the tin electrode is the cathode. Write the oxidation and reduction half reaction equations. Well, the half reactions are given, but those are both reduction. So we must rearrange the oxidation reaction to show the loss of electrons. So here's going to be our oxidation reaction, where you're losing the electrons and you're going from a solid nickel to nickel 2+ aqueous. And this is the reduction reaction, and we just keep that as is. Determine the complete balanced redox reaction. This is obtained by adding the two half reaction equations since the species and charge are already balanced. All right, you have 2 electrons on both sides, and the coefficients of our elements there match. Add them, these guys will cancel out, and you get tin 2+ plus nickel solid state gives tin in the solid state, and nickel 2+ aqueous. Determine E0 cell. Well, that's E0, the SRP of the cathode, minus E0, the SRP of the anode. So the SRP of the cathode is right here. That's the tin electrode, minus 0.14, minus the E0 SRP of the anode, which is minus 0.25, and we get 0.11 volts. Another reaction, and we have a different electrode here. Identify the cathode and anode, write the oxidation and reduction half reaction equations, determine the complete balanced redox reaction equation, and then determine E0 cell. Identify the cathode and anode. The anode is the electrode at which oxidation occurs, which is the electrode with the most negative cell potential. So that's going to be tin. Therefore, the tin electrode is the anode and the iron electrode is the cathode. Write the oxidation and reduction half reaction equations. The half reactions are given up here, but we must rearrange the oxidation reaction to show the loss of electrons. So this time that will be tin, which is losing the electrons, and the iron one stays the same. Determine the complete balanced redox reaction. This is obtained by adding the two reactions. This time, however, and we'll look up here, this is before we reverse the tin one, 2 electrons here, 3 here, so the 2 is actually going to be on the other side. Well, 2 doesn't balance 3. How can we get that to balance? Well, we multiply this reaction by 3 and this by 2. And that's what we have down here. So we have 3 tins gives 3 tin aqueous plus 6 electrons, right? 3 times 2 is 6. With the iron, we're multiplying the entire equation by 2. So now when we add these two equations, we've got 6 electrons on this side, 6 on this, they cancel out, and we're left with 3 tin plus 2 iron is 3 tin plus 2 iron. Determine E0 cell. Here's our equation, E0 of the SRP of cathode minus E0, the SRP of the anode. Now what's interesting about this is even though we have different amounts of moles, we don't care. This is an intensive property. So the SRP of the cathode is 0.77. The anode is minus 0.14, and we get an E0 cell of 0.91 volts.